I'll press the button. Good evening, folks.
Evening.
Hello.
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 Is this working? Is it on?
I don't know. Yeah, I'm waiting for YouTube to update just so I know things are actually working. Oh, there we are. It started. Cool. We're on. We're live. It's happening.
Perfect.
Well, this
Don't
is
you
exciting.
love that stream delay?
It's a bit nerve-wracking, isn't it? I suppose you'll get used to it eventually. Cool. So yeah, welcome. So this is the first virtual Kubernetes Edinburgh. Almost certainly not the last. Does mean that we can do something a bit different. So tonight we've got our first international speaker. So Hans-Kristian's here from TietoEVRY, and he's going to talk about building a bank on cloud-native technologies. We've also got Adrian from Container Solutions. I think pretty much everyone in Edinburgh knows who Adrian is. He's a bit of a local legend. He should be joining us very shortly once he's finished cursing and swearing at Linux, which doesn't appear to be playing very nicely for him tonight. Let's just ping on. Yeah. Okay. Cool. So yeah, Hans-Kristian's up first. So we'll get started in about 10 minutes or so. I just wanted to give a quick shout out to the folks at Lloyd's Banking Group. So they have very graciously offered to support our meetup. So if you checked the text on the meetup, you'll have seen that there were 5 Just Eat vouchers to be given away to randomly selected RSVPs. So those notifications went out last night, and I've had 4 of the 5 responses back so far. So check your meetup messages just in case you're the one remaining person who hasn't claimed their voucher yet.
It's a shame we
didn't
find out what food people ordered. Would have been kind
of.
enough.
That would be interesting. That would be interesting.
Maybe if you've got a voucher, send us a picture. Can you post pictures in the comment section on YouTube?
So I was going to say, so there's a couple of ways of interacting with the meetup tonight. If you have any questions,
I think Adrian's back. Shall we just?
Cool. Yeah. Add him
into the. Hello, Adrian.
Cool. I've not actually missed anything. I was here, just silently in the background.
Cool. So yeah, if you want to, so you can obviously ask questions via YouTube and post some comments in the chat. Also, there is a #meetup-Edinburgh channel on the Kubernetes Slack. So you're welcome to swing by there and ask some questions. That might be a good place to post some pictures if you do have anything particularly interesting that you've ordered from the takeaway that you want to share. I don't know. I tried to convince Lloyds to give us some extra for the organisers and for the speakers, but they didn't come through. So no tasty takeaway for us, at least not free of charge. Okay, so yeah, that was my preamble out of the way. So yeah, thank you to the 2 speakers that have joined us for tonight. Thank you again for graciously donating your time.
Thank you for having us.
Yeah, no worries. Good to have you here.
Yeah.
So Hans-Kristian, how are things? Yep. So you're based over in Bergen, and you are a very, very busy individual, and you organise several meetups yourself. Have you been doing any virtual events? Have you been involved in any virtual events?
Yeah, we have had some virtual events with the Google Developers Group that I'm co-organizing, as well as the Cloud Native group here as well. And actually, we are having a fireside chat with Kelsey Hightower in
no way. He's doing a lot of those.
in June. Yeah, he's doing a lot of those. So we're really trying to figure out some new and unique questions for him.
Is that? I guess it's for. Is that just for the Bergen group, or are you doing that as part of the Cloud Native Nordics?
That's part of the GDG Norway.
Okay, right.
Yeah.
Yeah.
Awesome.
Yeah. So really looking forward to that. And
did you manage to catch Kelsey's fireside chat with Ben Heinemann at the Cloud Native Virtual Summit?
Yeah. I saw that.
Yeah, I enjoyed that.
Yeah, absolutely.
I think Ben Heinemann set up like a crackling log fire right next to him. That took some beating. He took it quite literally as a fireside chat.
Not that I'm sure he needed that fireside in Tahoe or wherever he's holding.
Yeah, exactly. Just showing off for the sake of it.
So yeah, these virtual events, I don't know how others are finding them, but it's a kind of it's a different experience speaking at them, right?
Yeah, definitely. Yeah, and sort of miss little bit about the community and actually interacting with more than just the other speakers or the other organizer, because you really can't see the rest of the audience.
Yeah.
I mean, I think the whole of the kind of developer advocate industry have been struggling with this question, I guess, over the last 3-4 months. How do we make them more engaging? I should give a plug at this point for Software Circus last week, which was a really great experience, organized by Adrian's company, Container Solutions. And I think you did a whole bunch of stuff to try and build that into more than just a set of people on Zoom calls, right, Adrian?
Yeah, I think it went pretty well, actually. It's just, so even when we did the in-person Software Circus, which was like a conference in Amsterdam, and we ran it 2 or 3 years, and then there wasn't one last year. Even when we were doing that, we tried to do kind of different things and make it more fun, if you like, and a bit more interactive. And we sort of tried to continue that into the virtual one, and I think there was a lot of successes. Yeah, I was pretty happy with it. We actually had Kelsey for a panel, not a fireside chat, but a panel with 4 people, and that was one of the highlights, actually. But because it like nearly every single speaker dressed up, and I think it created quite a good vibe. So I think that was a success.
I should have been organized here and had a picture of both you and I in fancy dress to share, Adrian, for this group.
I'm sure I took a screenshot.
But if you're interested in viewing any of the talks from Software Circus, are they on YouTube, Adrian, now?
I hope so.
Anyway, softwarecircus.io, you can find all the stuff there. I highly recommend. There was some very interesting content.
Yeah. They might be editing them and uploading them later. I'm not sure.
Cool.
Yeah, so we have been experimenting a little bit using Discord and then having multiple voice channels where all of the participants in the meetup can sort of hallway tracks, either in between the talks or after the talks.
And how's that been working?
With mixed results. I guess it takes some time to get used to for most people. This feeling comfortable talking over the internet. Yeah. But at least then we got a little bit more engagement, or where I could actually then ask questions to the audience and get response.
Yeah, it's a bit more interactive that way. Yeah.
What I thought it was interesting at Cloud Native Virtual Summit that we at TietoEVRY and Container Solutions again put on 2 months ago now, that one of the first things that people did was self-organize to have persistent chat outside of the conference, which was also interesting. We talked about that as organizers, but hadn't really found a way where we could do it very easily, other than have a Slack channel or something completely separate, which then does give you you additional issues about moderation and how you make sure code of conduct's adhered to and all that stuff. But I mean, almost within the keynotes, people had already self-organized. Someone had set up some wasn't Discord, I don't think it was, but some text-based thing that folks were communicating on. So
some text-based thing, not IRC.
No, it wasn't IRC. No,
everything should be an IRC.
Use, Nick. I wasn't familiar with it.
IRC and some other thing. The 2 options.
I mean, this is the problem. The proliferation of chat apps is just, it's just ridiculous. We should all just standardize on IRC. That's my opinion.
Bots before it were cool.
Exactly. Everyone bust out the egg drops. Cool. Right. Should we get cracking with the first talk then? Are you all set? Hans-Kristian, are you ready to go?
Yeah, I'm all set. But once I start presenting, then I won't see you or if there are any questions. So Nick, please interrupt me if there are any questions, so I can answer them during during the talk. Yeah.
Okay. So are you gonna press the buttons here then, Nick? So I think Hans-Kristian needs to share share his screen, and then we can make the magic happen.
There we go. Oh. And screen, select screen, and allow. Yep.
Cool. Right then. In that case.
Yeah, just no, I can. Well, yeah, I can see you.
Okay, so I'll drop all of us out.
Yep. All yours.
Oh, okay. Yep. There we go. Yeah, I'm not sure why I don't get my presenter note, but that doesn't matter. Okay, so yeah, thanks for having me. Thanks. It's really cool to be on the Kubernetes Edinburgh virtual meetup. So today I'm going to talk about how we built Norway's first mobile-only bank on Kubernetes and a bunch of other cloud-native technologies. So my name is Hans-Kristian. I'm from Norway, or the west part of Norway, Bergen, very rainy city. In May, we had we had 5 or 6 days with snow, and it was raining all through our Constitution Day. But that was maybe for the better, since everyone was at home anyways, so we didn't really miss anything. I have two boys, 3 and 5 years old, so quite hectic days when the kindergarten was closed. Luckily, they have started to reopen now here in Norway, so it's a little bit more quiet on the home office side. I'm SRE practice lead at a company called TietoEVRY. It's a consultancy agency, or the largest consultancy agency in the Nordic region. I've been on the Node.js Foundation as a member there, on the build working group, and as well as the Docker working group, ensuring that we have the build and test capacity for Node.js, as well as a state-of-the-art Docker image for Node.js applications. And I really love open source, been an open source contributor for all of my life as a technology person. Yeah, so that was short about me. So, I'm going to talk about this bank that we built that's called Bulder, and I'm digging into the architecture and build and deploy and runtime and operations and so forth. And feel free to ask any questions. As I sort of said, I can see them now when I'm presenting, but Nick will shout them out. So if there are any questions, just write them in the chat. So yeah, so Bulder Bank, it's a challenger bank in Norway. It's actually owned and operated, so it's operating within a parent bank. So it doesn't technically have its own banking license, but it operates completely autonomous. And while the parent bank is more of a regional bank with regional customers, Bulder is operating as a national brand, targeting the entire country. So there were sort of like 3 main kind of key points behind the Bulder brand, or the Bulder Bank experience. It should be the best mobile banking experience that you could get. So I would say that mobile banking in Norway isn't terrible, but it isn't great. It's a lot of these just web. So we do have fairly decent mobile or web-based banking, but they just package those into a mobile sort of web container-ish for the phone, and just call it a day. I guess that was the easiest. And sort of you didn't get the snappiness, the interaction was laggy, and compared to how at least the more younger generation is expecting their mobile application to work, none of the banks were sort of up for the challenge there. And it means that you really had to write this from scratch, and it needed to be native. And that was sort of one of the, and then it should be, and from the more financial side, Bulder is aiming to have the most competitive mortgages with automatic rent adjustment and everything being automated. So having people out of the loop, not requiring too much on the customer service side, and helping people. Everything should be automated. You just open the app and you move your existing mortgage and you're home free. And sort of having this, removing this friction where I typically have to call my bank every once a year in order to sort of like ask them if the rate I'm getting is the real rate, and sort of threatening to just leave them for another bank if I don't get the rent that sort of I know that they can give you if you just ask them. And sort of that shouldn't be the case with Bulder. You should always get the automatically rent adjustments, and it should also be according to how much you have down paid on your mortgage, as well as the value of your house. We are getting multiple sources of information here in order to compute the actual rate that for your mortgage. And then focusing on having lots of value adds and integration on top, like everyone can do sort of key or basic banking, like payments and your credit cards and accounts and so forth. And we believe that like not trying to reinvent that, we're trying to sort of add value adds on top of that. So creating the bank, we sort of started from scratch. So we really had to like go for a very minimal product, and by minimal it was barely minimal. So we needed to have a completely automated onboarding experience. Of course, we needed to be able to see your transactions and your payments and your credit cards, and then getting push notifications when there were new invoices or purchases. And sort of we had one sort of like value added feature that no one had at that time, where you could just snap a picture of your paper invoice and it will just auto fill in. And that was the first integration that we sort of built into our banking platform. And then from there, we have focused on a new subscription management. Again, another service that we have integrated. So you show all your active subscriptions and how much you pay for them, as well as sort of this what we call transaction 2.0, where we want to have more richer metadata instead of these very cryptical names for the different shops and so forth. We really want to have a human readable name. We want to have a logo, a category, place it on a map if that was possible, and more functionality around your economy and seeing into your future and the past of your spending. So sort of the team that built all of this, it was no more than these people here on the technical side. We had a CTO, one front-end developer, a web front-end and back-end, and a couple of cloud engineers. And then you can see really focus on the mobile experience with design and UX and the Android and iOS developers making half of the technical team there. And of course, really needs to mention that we are building on the shoulder of giants here, because we are not in the game of making these core banking functionality or remaking those. We're actually building on top of the banking APIs that the parent company sort of provides, and that is sort of like goes hand in hand with this PSD2 regulative that's sort of been introduced, requiring banks to have APIs for all the banks. So we actually built on top of those, actually dogfooding the APIs, making sure that it worked. And it didn't always work. So we were able to actually pull this up, going from no code written at all, only an idea in just 10 months. And we thought that was really unbelievable. And no one really thought that was possible. So actually in August of 2018, we started the work here. And in June, just 10 months after we launched the first, it was a public beta with real customers, but they had to sort of be invited. We had a huge waiting list. And by September, we sort of opened the floodgates so that everyone could become a customer. And we sort of, this, at least we believe that this was possible. Well, given the sort of the parent bank didn't have much cloud presence at that point and sort of have made some other choices. And we believe that the only viable option for us in order to actually meet those deadlines, because that deadline by June had sort of been put in stone, that if we were to follow through with creating Bulder, we had to have something out by June, and then it had to be publicly by the at the autumn. And we came back and said that we can do this, and this is possible if we can use Google Cloud, and they sort of allowed us to do that. And there were two primary reasons why we wanted that. The mobile developers wanted it because of the recently purchase or acquire that Google had did with a company called Firebase, which is a suite of mobile sort of backend technologies and mobile tools and services, or everything that your mobile developer really want to like hit the ground running with your mobile applications. And then of course it was the rock solid Kubernetes service, the Google Kubernetes engine, where we want to host all of our backend services. And sort of the simplest architecture diagram that I could possibly show is something like that, where we have the mobile applications talking with this Firebase database, and then that in turn is talking to our Kubernetes cluster or the application within our Kubernetes cluster, and that again is talking with the open banking APIs from the parent bank. And for those of you who don't know Firebase, there's a lot of different tools and services here. These are the sort of the 9 most important to us, at least. It's a NoSQL document database, real-time database, where you have bidirectional data population. You have integrations with serverless functions and user authentications. We were able to just with a couple of lines just get all of the connection going securely. We actually had to turn off some security features in order for our penetration testers to be able to peek inside. So we sort of really got a confirmation that that's a rock solid authentication scheme there. On the more operational side, we get crash data, we get performance monitoring, we get the real test lab with devices and video back on how the application is performing during our test runs, push messaging, analytics, and remote configuration to do A/B and feature toggling of functionalities out in at the customer side. And sort of Firebase is a sort of interesting database. It's a NoSQL document database, but sort of it does have a hierarchy. So you can sort of think about like a tree and a leaf node. And this makes it really nice authorization wise as well, because you can sort of imagine that each of our customers has one root object, and then all of the sort of, they call it collections below that belongs to that one user. So we can just set permissions on the root object, and then that propagates all the way through the tree, that part of the tree. So it's really nice since, as sort of the diagram alludes to, the clients, the mobile devices, talks directly to the database, which sounds a little bit scary. And like no schema, no problems, no. Think again, there of course it solves some problems and it creates equally amount of new ones. And sort of the most obvious problem was that if you don't have a schema, then you sort of end up with different clients or a different version of the clients writing different data. And of course we ended up that I don't think it was many weeks out in the project, we just realized, oh, the Android app writes this data in one way and the iOS writes it in another way. So if the user happened to switch device and log on, it would just crash because it assumes the data would be slightly different or adhere to a different standard. So we solved that using the Open API specification, so where we could sort of define all of our objects, and you sort of have this very nice flow where you can write the specification, you can then verify, you can have manual review, you can have automated verification, and then you can deploy it, you can create an artifact out of it. So we sort of created all of these different user object types. So we have accounts, and we have cards, and we have payments and transactions, and whatnot, and the different versions of those. And we then can sort of compile client libraries for iOS, for Android, for Go, and for Node, and whatever sort of client language that we would need to sort of interact with these models, and ensuring that this was actually according to our sort of standards or spec, as you would say. And talking about the mobile, I'm not a mobile developer, so this is what my knowledge about the implementation on the app side goes. But the Android app is of course a native app written in Kotlin, and the iOS app is a native app written in Swift 5. And it was sort of a decision going really from the beginning, that if we were to realize this, building the best mobile experience, we really had to sort of create the build this natively, not using some cross-device framework. So that sort of course made it take a little bit longer time, but we believe that we have downpaid that sort of now, where we are really efficient with the development at this point. And then we have a automated build and deploy pipeline. So using Google Play for the Android app and TestFlight for the iOS app. And then builds automatically to our internal users. And then we have a public beta channel that sort of get very frequent releases as well. And then we have sort of a stable channel, which is the entire audience or entire customer base. So that was that was Firebase. So that was a really important part for the mobile developers. And then for the backend developers, then we sort of believe that Kubernetes would be the right fit. And that was a little bit controversial at that time, because the parent company had sort of like gone to the next level, and that to say they wanted to go completely serverless. Ended up reverting on that decision later and going with Kubernetes. So we sort of like felt that we made the right decision there. But we felt that was the right abstraction between like not having to manage the virtual machines, and it gave us the flexibility that we sort of didn't believe that we could get by only using something like Cloud Functions or App Engine. And I guess don't need to really explain Kubernetes for this audience. And you have this very cool API. So I have a Raspberry Pi cluster at my home here. It's the same API that I get from all of the different vendors. So that was sort of really nice, being, of course, to some extent agnostic, or that wasn't really a selling point for the builder, but was this very notion about being API first, that we want to automate everything from the infrastructure and to the application and whatnot. So sort of having something that was really solid API was sort of topmost important. It's modular, composable. I'll get a little bit into that later in the talk. And then this notion of self-healing. So sort of if you configure Kubernetes correctly, you get this liveness and health checking. And that sort of have enabled us to actually sleep at night and not being wakened too much on by things failing, and sort of coupling that with sort of a sort of self-healing architecture, where you have using message queues and making sure that if something goes down, then you just keep on building up this queue, and once it gets up again, then you can just replay from this queue. Sort of allows the system or the whole architecture to sort of be self-healing, and once things get up and being external dependencies and whatnot, the system just continues where it left off. So back to the architecture here. This of course is a simplification. And we sort of really at a really early point sort of saw that this Firebase acquisition wasn't really that well integrated to the whole Google Cloud ecosystem, and still to some point isn't today. So we sort of had to completely separate those into different projects that would be accounts for those of you using AWS, or subscriptions for those of you using Azure. And that sort of had to do with the permissions that we had to delegate to the developers that were accessing those. Once you sort of gave access to some of the Firebase functionality, you suddenly gave access to a lot more that you really didn't want your developers having in production. So splitting those sort of solved that immediate concern. And then there is one important kind of part here to the architecture, and that is that the way that you sort of subscribe to changes from Firebase is using Cloud Functions. So we had to use some Cloud Functions in order to subscribe. That's sort of a limitation of the SDK and sort of what it was built for. So we did need to have some functions, and in the beginning they didn't support Go, but we later then rewrote all of our functions in Go. And then using PubSub in order to just notify our backend applications inside GKE. So very early on, or I would say midway through, the compliance sort of started asking a little bit more questions, of course, doing their job. And we sort of, they sort of asked, oh, where is the data when it's Firebase? Yeah, it's in Europe. Where is the data when it's in PubSub? And we sort of had to dig through, and that is a global, at that point was a completely global service. And we saw that, yeah, the data is on the planet Earth, and that wasn't good enough, I guess. So we couldn't use that. So we used another system called NATS. And that wasn't the first time I'd heard about NATS, but it was the first project that really got to use it. But it's a high performance messaging system. It's actually fairly old in technology years. It's actually first released in 2013. That was sort of the most surprising to me at that point. And it's by now an official CNCF project, so it fits quite nicely into the whole cloud native ecosystem, and they have a really nice integration with Kubernetes as well. And being a static binary written in Go, it's also very performant and reliable to operate. And it's actually very well integrated with Kubernetes. So Kubernetes, for those of you who are familiar, you know, the Kubernetes has this operator patterns, or at least that's what they are called, but they have this custom resource definitions where you can then extend the Kubernetes API and not only have pods and deployments and services and ingress, you can have your own. So one popular operator is the Prometheus operator that extends the Kubernetes API to then have a Prometheus resource where you can just describe how you want your Prometheus server to look like, and the Prometheus operator will then be tasked to sort of build that out of the more low-level building blocks that the Kubernetes API provides. So this operator pattern being one, and there's being one sort of way of managing more complex or stateful application, and Kudo being another sort of framework for managing stateful applications inside Kubernetes, because Kubernetes doesn't really handle that very well. When you upgrade it, it would just very blindly just start killing nodes and not dealing with more of the more advanced topics. And Kudo or operators can sort of accommodate that whole life cycle for your more stateful or complex applications. And it sort of also comes a little bit back to the SRE mantra, where sort of operations is a software concern. You really want software to do the operational work and not tasking your humans to sort of be always on watch and making sure that this is doing well. So NUTS as well. NUTS also has a very nice integration. It has operator, actually two, because there are two parts of NUTS. But for the NUTS cluster, you have a NUTS operator, so you get these custom resource definitions, And then you get the NOTS operator deployments. So when Kubernetes sees that there are some NOTS resources being inserted into the API, it will sort of make sure that the NOTS operator is the one that handles those and not the controller in the default controller in Kubernetes. So it then allows you to just say that you want the NOTS cluster, you want to have it this version, and you want this many nodes in your NOTS cluster. And the NOTS operator will make sure that that is actually deployed, all of the pods are up, and you get a nice service to actually access your NOTS cluster. You get one other sort of very nice resource as well, and that's NOTS service role, where you can actually say what privileges your service account, that being a Kubernetes service account, should have in your NOTS cluster. It will then give you back a NOTS token as a secret that you can then use inside your application. Then by then you can then start talking with your NOTS cluster. So this is really, really nice to sort of package inside with your application, and being able to manage all of the access control mechanisms through the Kubernetes API is really, really convenient and a nice way to handle that, and not having to deal with some external interface or API. So that was the NOTS part. And then we also had this sort of, to this extent, ongoing issue that NOTS, this question here, isn't running outside of the Kubernetes cluster. It's of course running inside it. And sort of the Kubernetes cluster is running in one VPC and functions is running in another. So they actually run in different regions due to where they are available. And it sort of ended up that we had to do, in order for the functions to access the NOTS cluster, we had to have this gateway and then appearing between the VPCs. But we ended up at that point exposing the load balancer for NOTS as a public IP, and then using server certificates and client certificates as well as a token for authenticating, because this VPC, serverless VPC access gateway, wasn't available in the correct region at that point. And sort of got thinking, what if we could run these more serverless functions inside our Kubernetes cluster? Because sort of having some cloud functions, some functions, and most of it inside Kubernetes sort of creates a little bit extra burden. The development flow for the cloud function isn't that well compared to development flow for your Kubernetes apps. And sort of been working on looking into if we could then run these functions inside our Kubernetes cluster. And it looks like we might be able to do that sooner than later. There's this Knative project comes out of Google and IBM and Red Hat that is sort of building blocks for serverless containers inside Kubernetes. And Google has a manage option with Google Cloud Run. And it runs on top of Istio, so we had to sort of get Istio going before we can start moving into this. But this is something that we are really looking into, and we're sort of, the only thing we are missing is this trigger mechanisms for when data inside the Firestore database is changed, and then triggering these serverless containers and getting rid of these cloud functions, which is sort of not too good to work with always. And for our backend application, we started as a sort of all of the APIs have been written, or microservices have been written in Go from the start. At the beginning, we had to write the serverless functions in Node.js because Go wasn't supported at that time. We've since rewritten it, and most of the applications are now using Go. And then we have some Node.js for the Bulder Bank and Node, as well as an administrative user interface, but mostly in Go. And that's been treating us very nice. We are actually at Go 1.13 now, I believe, starting to migrate to 1.14. And the sort of the build and deploy pipeline is fairly like standard at this point. We have been sort of investigating whether or not we should go with a more GitOps approach without having really like finding a need for that and sort of the development flow that we really want to have, the ease of use for developers. So currently it's a very sort of synchronous flow where you merge your code into a master branch and then CircleCI automatically starts up. And then, of course, fetches and build dependencies and then run all of the syntax, the linting and unit testing. And we have source code scanning using SonarCloud and dependency scanning using Snyk. And build and deploy the images. They get signed and sent to a notary and to the registry. And then we deploy using Helm to our Kubernetes cluster. And first we deploy to the test environment, and then we deploy to production environment. And it's sort of been working really, really nicely so far. But with that said, we are now at the point where we are looking into sort of starting to do a little bit more of canary testing and sort of deploying new versions in parallel with existing ones, and then maybe splitting traffic and doing some. That's why we have started to look to move more into Istio now. And sort of, yeah, we have this of course using GitHub and the whole GitHub flow with everything having to be reviewed by your fellow teammates. So we only have like this one rule that needs to have one review from one of your team members, and then everything is sort of good. And we're trying to then look through what are the common sort of review feedback that gets submitted, and then sort of trying to automate those as much as possible, so we can then not having the humans doing the same reviews over and over again, and sort of freeing them up to do work on more new things. So this is the architecture, very asynchronous for the flow, and most of it is this way, where our users will insert whatever operation they want into the Firestore database, picked up by the functions, sent over nuts to our backend services, and then we talk with the open banking APIs. But we do have some more synchronous endpoints as well, where we have, for instance, this when you log on your first time, you have to go through this onboarding and verifying that you are who you are using the Norwegian bank login called Bank ID. And then we have some other API functionality that are also synchronous in nature. So we started up using sort of Google's proxy technology or API technology, just called Google Endpoints. That sort of didn't work out. It sort of was really pain in the arse to work with. And we ended up replacing that. That was the first service that we replaced with Istio, and used the authentication mechanisms, or extending Istio authentication functionality in order to validate JWT tokens. And then investigating more into Istio, it's a service mesh control plane built on top of Envoy proxy, and Google has a managed version in GKE, though we have at this point installed it ourselves in order to more fine-grained control what version of Istio we are running in test and production. These with client-side load balancing, timeouts and retries, monitoring, tracing, and that was sort of like the reason that we wanted to move more into it, is that by this point we do have quite a number of microservices, and having a standardized way of observing all of them and the traffic between them is sort of a really, really important thing for us. So I won't bore you with all of the details. The way Istio works is that you get this proxy container that deployed alongside your application, and sort of intercepts all the traffic coming in and all of the traffic going out, and it reports that traffic back to a centralized control plane, as well as some rules and on how the traffic can flow. And sort of what we get out of that is that we get this observability here, where we can in real time actually see the flow of traffic. So I believe this is just an example application where you can see the traffic comes through the ingress gateway to the product page, and then it's split into 2 requests, into details and reviews, and the reviews makes a request to ratings. And actually this was taken from today, where we had to debug some connection issue, or we saw that we had some issues in one of our bank the admin portal, and it was really easy to actually at least pinpoint where in this path is the most likely problem to be placed, and we can actually see that it was to this Alert Central API where traffic didn't appear to go through, and we could then narrow our debugging focus into that. So we're using this this user interface here is called Kiali. So we're using that as sort of our first respondent to whenever we have alerts that sort of indicates that something is amiss. Then we open up that and we go using that to sort of triage where we want to dig deeper in, and then we sort of drill into the logs and the dashboards and ultimately probably the logs as well. And sort of what we have sort of modeled a lot of our decisions, and sort of the team that I'm heading at Bulder is this site reliability engineering practice, sort of made forth by Google, but sort of embraced by other organizations as well, and sort of as the way it was happened when a software engineer is tasked with what used to be called operations. So sort of Bulder doesn't really have an operations department. We don't have sort of on call to that extent. The developers are responsible for their application, and sort of we have an SRE or a platform team that's responsible for building the platform and making sure that the automation and all of the tooling is working properly. And sort of the observability stack has sort of been going a little bit into that, and we very early said that, or actually sort of not banned logs, but we didn't really told that we are not going to go into more structured logging and sort of making sense out of unstructured data. All of our services and applications needs to be instrumented using open metrics format, open metrics, the standard format for delivering metrics. And then we wanted to use tracing in order to see the traffic between them and sort of the span or flow of traffic. And of course, using Prometheus and Grafana for the metrics part. Not going into how Prometheus is, but sort of building up dashboards and sort of having all of this data readily available using in a very structured way where you can query it and search through it and so forth, that you don't really have in using something like unstructured data and logs. And then for the using Stackdriver for logging, of course, and also Stackdriver tracing for the tracing backend, and then using OpenTelemetry for instrumenting the tracing format that is. And and that's sort of getting this span where the request comes into one service and then makes subsequent requests to other services, and then seeing the timing and the headers and really drilling down into one request, and in order to sort of debug and profile those. I think that was mostly about it. Are there any questions, Nick?
Yeah. So we had a few questions. Let me just scroll back to the comments. So there's a couple of questions that came in from Chris Plank. I think one of them you sort of answered fairly early on. So he was asking if what you were building, is it just the mobile layer, or do you interface to a core banking engine?
Yeah, we are interfacing with, so we are building the mobile layer, and then we are interfacing on a core banking engine underneath, and that's through these PSD2 open banking APIs from the parent bank.
Yeah. And then he had a follow-on question, which was on the payment side, SEPA Classic integration. How did you get around payment gateways being traditional on-prem based rather than APIs available over the cloud?
Yeah, so that's sort of been this EU sort of regulation that has sort of required all banks to actually deliver these types of payment APIs over the internet. So actually, and that's called PSD2. So that's all of the banks at part of at least the European Union been sort of working very hastily on getting to that time where they had to sort of publish those, and then getting some additional APIs that aren't covered by the PSD2 standard in order to sort of get all of the experiences that in the Bulder Bank that we wanted.
Cool. I'm not seeing any other questions filtering in. I don't know if people want to give people a minute or two just in case they're busy typing away. But yeah, it's good talk. I mean, so that's probably the 6th or 7th time I've seen it.
Yeah, Nick and I, we traveled through most of Denmark, and then we went to Oslo, and then to Bergen, and then Nick gave his Kudo operator talk, and then I gave my Bulder talk. Yeah,
comedy double act. I noticed that you were still in the habit of mentioning Kudo as well during the operator section. So it was nice to get another shout out for the Kudo project. Yeah, that was a fun week.
Yeah, definitely. Yeah,
I wish I'd have had more time to actually see, the countries and the places that we visited. We seemed to spend most of it either on planes or trains or.
Yeah, that was sort of the.
Yeah. Welcome to my life.
Hang on, there's a very small violin around here somewhere for you, Matt. Cool. So Chris has followed up with a comment. So thanks. So only the mobile layer that's using the cloud then.
Yeah, well, sort of we have our sort of cached up view of the data. So we do have sort of a copy of all of the data, and then we have our integrations and enrichment on top of that as well. But you are correct that the master data lives in the core banking platform. So when we fetch that, and also when we carry out the payments, that goes through that. That's correct.
Yeah. Cool. I suppose this is how you deal with all that legacy. Is you build newer abstractions that provide modern APIs in front of those legacy systems. There's no way of getting around it, I guess.
Yeah, definitely.
Cool. All righty. So I don't think we've got any more questions. So if you're ready, Adrian, we'll get yourself. Oh, hang on. Sorry. So another Nick has just chipped in. Yeah. Last minute with a question, and given that he's called Nick, I've got to give him a chance.
In the nick of time.
In the nick of time, exactly. Yeah. Okay. So he asks, can you please explain how you use the open log format?
The open log format. Well, so we don't, as I sort of, maybe I sort of explained it wrong, but we don't do logging. we have logs for audit and for debugging, so we don't really have any standard. You just put that on SD out or SD air, and we store all of that. So we have those. We are using the open metrics standard for all of our metrics. So that's the standard that Prometheus put forward, and then it's been a standard in its own, and other systems have started to embrace that and adopt that. So it's more than just Prometheus. We can actually pull out Prometheus all from a mix and then just replace it with something else that can read open metrics. And then we have the open telemetry for the tracing part.
Cool. Sounds good. Excellent. Well, thank you again for coming along tonight. Like I said, that was an awesome talk. I might have seen it 6 times, but I've enjoyed it every single time. There's so much information in there. It's so densely packed in terms of information. It's learn something new every time. So yeah. Thanks again for coming along.
Yeah. Thanks, Nick.
Do you want to give any shout outs to any of the meetups that you run? Have you got any virtual events coming up that you want to promote, and just kind of maybe there's some people that are watching this tonight that would like to come on to one of your meetups?
Yeah. We have a fireside chat with Kelsey Hightower coming up with that's a Google developer group in Norway. So I'll make sure I can probably post a link to that after the.
Cool. Great. Yeah. Excellent. Yeah. Right. Thanks again for your time. And next up is we've got Adrian from Container Solutions. Like I say, I think most folks that are most people should know who Adrian is, I'm sure.
Everyone in Scotland knows Adrian.
Yeah, everyone. Yeah. It's growing from Edinburgh now to all of Scotland. So Adrian's got a project called Trow, which is it provides a container registry for running inside Kubernetes. If I'm remembering rightly.
That's a pretty good explanation. Thank you.
Cool. That's it. Talk done. It's written in Rust. Did it start off as a bit of a pet project as a way of learning Rust, or was it? What was the motivation for developing it?
I mean, Rust is pretty good. Well, Rust is a pretty good fit for microservices, full stop, but it was a pretty good fit for what we're doing as well. But it is the first major thing I've written in Rust, so it was a bit of maybe I should have picked something easier to start with. But.
Something a bit more straightforward, yeah.
Is it pronounced Trow? What's the?
It's Trow. I should probably add a slide in the pronunciation. There's a small story to it because. It was called something silly at first. What was it? It was originally named after some king. Like Caon or something. Anyway,
right.
But I changed it to Trow, and now Trow is in Shetland folklore is like a fairy. Or troll. It's more like a troll. It's basically the same as a Norwegian troll actually. And they live in what's known as a Trowy now and things like that. But it's Trow.
But Norwegian trolls are huge, though, aren't they? I thought aren't Norwegian trolls like giants?
Yeah, they're giants, and then they become these mountains whenever the sun hits them.
Yeah, because there's several famous troll walls in the climbing scene in Norway.
Yeah, that's correct.
Okay. Well,
so they spend a lot of time posting comments on Hacker News.
I see what you did there.
Oh yes. Sorry, Adrian.
In Shetland folklore, they're quite small and they play fiddles and take people away and live in Trow now. So maybe more like fairies then in Shetland folklore.
Cool.
Okay.
Right. Yeah. Let's move on then. If you want to share your slides, we can get this teed up.
I have realized something terrible. And obviously I need to set up my working environment better. Basically, how well lit my camera is depends on the current slide. So when I have a bright slide, you can see me better.
And you're well lit. Yeah.
Because it's kind of here on the monitor. Right. Share screen.
So I'll
select window. I think it's this one. That looks good.
Are you pressing the buttons here, Nick?
Yeah. I'll remove ourselves. Okay,
hey, all looks good. Okay. So yeah, I kind of wish this talk is about Trow, but it's also just about container registries and what's sort of next for container registries and what people are working on at the minute. And registries have been part. See, you can see me better now because it's a white slide. Anyway, registries have been part of the Docker ecosystem since the beginning. The Docker Hub was like essential to containers going mainstream. An initial Docker experience, when you ran sort of Docker run, Debian, Echo Hello World, wouldn't have been the same if you had to, spend ages finding and sourcing and installing the Debian image. But in the last 5 years, not a lot has happened with container registries. They've really not evolved very much. And I actually think they should. I think there's a lot more they could be doing and a lot more they could be doing for us, especially in the sort of modern world of like Kubernetes clusters. So I'm kind of going to, in this talk, highlight some of the ways that I think registries are failing us or could do better. and talk about sort of where we are working on those issues and various solutions, including Thrive. Yeah, so this talk will also, what's my next slide? Yeah, this slot will also like sort of motivate why container solutions are working on Thrive and why we think we need another container registry, if you like. Yeah, so Thrive is like a container solutions open source registry and image distribution solution. It's still very much in heavy development. Also, the logo needs to change. My problem is I can never tell if it's like coming out the box that's pointing towards me, or that you can see the outside of, or a box you can see the inside of, and I keep switching between the two. It's really, anyway, so I need to fix that. But the main thing about Thrive is that it's intended to run inside a Kubernetes cluster and integrate with a Kubernetes cluster, which I think gives us, means we can provide extra features and stuff not found necessarily in other solutions. So what makes Thrive different from other registries? Well, most other registries are kind of focused on being sort of a complete archive, like so all your images for all time for your organization, including test and development and so on. Whereas Thrive kind of focuses more on what I've called the working set and securely and efficiently delivering that to the nodes in your cluster. So what do I mean by working set? So that's a set of images that's required to run your application. So if you were given a completely fresh Kubernetes cluster, what would you need to get your application up and running? It's not the full history of all your images. It's not all your development and test images. It's a much smaller set. You might need one or two generations back to allow for rollback and so on. But it's a more constrained set than perhaps other registries typically work with. There's no reason you can't store all your images forever in Thrive. It's just not really the focus, if you see what I mean. And quite often you may use Thrive alongside another solution, which would be storing all your images in history for auditing or retrieval purposes. Yeah, so we said Thrive normally runs inside a cluster. It doesn't give you a choice of storage backend. So if you go and look at Docker distribution, like one of the reasons they had a really hard time implementing delete, or not even delete, just being able to clean up images, was that they have so many different storage backends, including stuff like S3, and it was very hard to keep things in sync. So Thrive sidesteps all that and just says, right, we write to a volume, and it's up to you where that volume lives. You can obviously configure that in the normal sort of Kubernetes way. I definitely want to focus on security and auditing. So the registry should really give you an idea of what's happening in the cluster. What images are being used, where they're being pushed, or they're being pulled, and what happened when, and so on. It's also intended to be lightweight, which brings us back to your point about Rust. So yeah, I intentionally use Rust because it compiles down to a binary. It doesn't have any GC pauses, and it allows us to create a lightweight web service effectively. That's really quite useful in sort of the microservice world, and especially when you don't want to place a lot of strain on the cluster. So if you run in Thrive, it shouldn't cost you a lot of extra burden and multiple extra nodes just to run Thrive. Okay, so I've basically got sort of three different tales, if you like, of where I think registries are letting us down. And the first one to do with artifact types. It's a mild digression. I should say I did get a little bit obsessed with Free Logo Maker when I was writing this scenario. Actually, if you go and look up for free logos online, it's like the first 4 or 5 hits are all ones where you go through the whole process of, say, the free. You go through the whole process of generating a logo, then it wants you to pay 30 quid to download it, which is quite annoying. But if you go to Namecheap, they've got one that's as good as the other ones and is actually free. Because obviously they want to sell you a domain name, but they don't force you to buy a domain name. Okay, so imagine you're a developer. You're working on a new top secret project for Fantastic Corp, free logo generator. I'm actually quite impressed by the results from free logo generator, by the way. And you're developing Zodis. So this is a new, let's say, sort of etcd style storage thing, specifically for your use case. Next slide. Yeah, it runs on Kubernetes, and you're just about ready to do a 0.1 release and get the rest of your organization involved and show it off to them, install it in a cluster, let them try it out on their own test clusters, and so on. And so, you're writing the release notes. The first thing you do is upload your container to your organization's Docker registry. Okay, so Zodis is pretty much one container, and we can push it up to the Fantastic Corp registry like this. So that's pretty normal. But once you've done that, and you want to write the announcement email, and you want to put in like a one-line install instruction, you've got a problem because you're using Helm. And so how do people get the Helm chart? You could tell them to clone a GitHub repo, but it's a private GitHub repo just for your organization. And it's kind of a lot of extra work to put your users through. You can't use the Helm hub because it's a private thing. So what do you do? Well, ideally, you want to do something like this and just push it up to your Docker registry. Because, in my view, and a lot of other people's view, a Docker registry or a container registry should really be allowed to store a lot of other artifacts. And in my view, it should store everything that your sort of cluster requires to run that isn't not normally stored inside, like Git or source control. So all sort of binary artifacts and things like that. The examples being Helm charts, OPA stuff, Open Policy Agent, if you've ever heard of that. CNAB bundles, which is the diagram on the left. Can you see my cursor? No, you can't. And yeah, other Kubernetes stuff possibly, but also potentially things like Maven jars, Java jars, I guess, or NPM packages and so on, are potential candidates for being stored in a container registry, as far as I'm concerned. And I'm not the only person to think that way. And there is work within the OCI and also Microsoft of this ORAS project. So the OCI is you've probably heard of the OCI. They do the standards for the Docker image format or the container image format, OCI image format, and the sort of container runtime, which is effectively run C, which is part of Docker. And that's all defined by the OCI. But they also do the distribution spec. And I should also say that the image spec itself defines sort of your layers and how an image is composed, which does impact on how container registries organize and give you data, if you like, because the images are formed of layers, you actually download each layer separately, as you probably noticed when you do Docker pull. So the way that images are organized does have an impact directly on registries. But there's also the OCI distribution spec, which is basically defines what it is to be a conformant registry. The distribution spec is still sort of fairly new and still being worked on, but they have been working on support for various artifacts. And this ORAS project is OCI registry as storage. And if you run that against a compliant OCI registry, which isn't all of them, you should be able to upload any artifact type to the registry. And also, like 2 weeks ago, or however long the Harbor ago the last Harbor release was, Harbor, which is it was the VMware, it's now CNCF project. They announced support for multiple image types, or artifact types rather, and you can see it in this screenshot. There's like a CNAB bundle and a Helm chart, which you can download from Harbor today. And they've made a big fuss about its announcement, but really it just works because they're an OCI compliant registry. And actually, I should say, I will give props to Harbor for their logo. I think they win the logo wars in registries at the minute. And this is Google. So Google have the container registry, but they also have a single artifact registry. And I think they should get onto the free logo generator, and that would help them a lot because they should have like a little logo up there. But anyway, so this is quite interesting. I hadn't noticed this until I started doing research for this talk. But the artifact registry is the next generation of container registry. It doesn't it's still on beta, so you still got to like request access. But if you read the page there, it does say that as well as storing container images, it's going to support stuff like Maven packages and NPM packages for JavaScript, which I think is quite interesting. So they're clearly thinking along the same lines that a registry should store everything the cluster needs. And this is Azure. Again, they need to get on free logo generator. Yeah, if you look down the bottom on the sort of the second point in, they say they're an OCI artifact repository. So again, you can store various types of artifact. Singularity, if you haven't heard of it, is the sort of HPC version of a Docker image. But again, they should really be able to store anything. And Trow, so I finally got around to testing like ORAS and pushing up Helm charts yesterday. And yeah, it worked out of the box. So I thought there'd be some like bugs I needed to iron out to support different media types, but it actually just works. So if you are an OCI compliant registry, you can just upload any sort of artifact today. But I mean, it is dependent on your client. So that ORAS project that I was talking about does, that's effectively a client that allows you to push up various artifact types and set the media types. And this is a screenshot of like me testing out the Helm chart uploading. So if they do Helm chart push, and I had to do it on localhost because I had the registry running on localhost and there's issues with TLS. But you can see I'm basically doing Helm chart push, localhost 8000, and I can upload my Helm chart, and then I remove it and download it again. And that's to the try registry. So that was pretty cool. And so actually, it turns out for this scenario, assuming you're using an OCI compliant registry, you can just push your Helm chart straight to it, which I suspect most people aren't actually aware of yet. Okay, so your launchers, see my camera's going dark. So you can see, so after that, we can write the announcement email. Azure's announcement email goes out and we have a successful launch. Okay, the next thing I want to talk about is a little bit on security and discoverability, which again, I think is a big area that's lacking currently in registries. And there's not so many good solutions at the minute. So if we are asked to like look at Fantastic Corp's Kubernetes setup and their cluster and do a security review on it, one of the first things you might do is just look at all the different deployments that are running. So in this case, I've set up a silly test cluster, and you can see we've got some of the EasyQL running, something called Hello, something called Redis, and Zodis running. Plus try was a registry and all the various kube system stuff. It is JKE, as you might be able to guess by Event Explorer, not sure. And then you can dig down into any given deployment. And from deployment, you get replica set, you get pods, from pods, you get containers, and from containers, you can see what image is being run. So here we can see we're running Redis image. Now, as you're probably aware, that means Redis latest from the Docker Hub. More usefully, though, it does give us the SHA hash. And the SHA hash, as you're probably again aware, is also known as a digest, and it gives you a content, what's the word? Content addressable? Content-based? Anyway, if the content of the image changes at all, including timestamps or anything at all, the SHA would change. So you can verify you've got the image you think you have by the SHA hash, and the SHA hash can only refer to one image. So if we go on to, or at least when you go on to if I went onto the Docker Hub when I made these slides, and we look at Redis latest, we can see that digest. And that's really quite nice. And we can see the digest is 49E8. And if we go back to this slide, we can see it's 49E8, so it matches. So now I'm pretty certain that the cluster is running the latest version of Redis, and it is, Redis from the Docker Hub. It's not like something masquerading as Redis that a hacker's put in place. So that's, a really useful thing to be able to do, to like verify something is what it says it is. But imagine in a week or two, or maybe today, I've not checked, I go and look at Redis latest. This digest is going to change. So how do I verify it is Redis latest then? And the answer is, I don't actually know. You probably can do stuff with what's a security sign solution? Notary. But very few people do that, and it requires a fair bit more work. So yeah, it then becomes difficult. And I accept this is a very informal way of checking anything. You really want to do checks like this automatically. But all the same, it seems a bit crazy to me that I can't go and get the history of tags, for example, for Redis latest and verify that at least at one point in time, this image did point to Redis latest. And that's actually something I've set up in trial already. So if you go, there's like a manifest history endpoint, and here we're asking for Zodus version 0.1 and the manifest history of the image. I put it through JQ to make it look a little bit better. And what it does is it tells you, okay, at the minute, it points to this SHA hash, but previously it pointed to this SHA hash, and before that it pointed to this SHA hash, and it gives you the exact point in time at which this was the SHA hash and so on. So you can verify that your image matches the SHA hash, and it was at one point Zodus 0.1, for example. And I would like to see other registries offering something similar, and arguably it should be part of the spec, but it does put a little bit of strain on people providing database functionality, essentially. Yeah, and then you might point out, well, you shouldn't really be using Redis latest. That's not a very good tag to use in production, and you'd be quite right. The correct way to solve this problem is to use a fully sort of proper tag. And actually, you should consider image tags in Kubernetes to be unique and immutable, or use image tags that are unique and immutable in Kubernetes. Otherwise, you get into problems. I mean, the obvious example is like if you have a deployment that references Redis version 3, and then a security update comes out for Redis, for the next version of Redis, and you want to update your image. If it's still Redis 3, you can't update it, because what you'll do is you'll do a kubectl deploy or whatever. And it's not a deploy, what is it? Anyway, you'll try and deploy the new version, but because the YAML hasn't changed, because the image name hasn't changed, then it'll just say, well, there's nothing to update. And that's because effectively in Kubernetes, Kubernetes basically pretends that image tags are all unique, which is a problem, really. So when you're deploying software in Kubernetes, you really want to use an immutable tag. So for example, you might want to use something like the short version of the Git hash, or even the full version of the Git hash after the version. So we've got 0.12, and then C10.226 would be the Git hash of the repo that was used to build Zodus or whatever your software is. You can also use a date and a build number. So here, I've got the version that was built on the 20th of May. And was the first version to be built that day. And that in Kubernetes terms is a lot better than using something like Zodus latest or Zodus version 0 or something like that. But that's not to say that these other mutable version numbers aren't useful. It's just that in Kubernetes, you shouldn't be using them. And yeah, to be honest, I think we should have support for both immutable tags directly in registries. So I would like to be able to tag a repository as being immutable. So if I push something like this, 0.12-C10.226, I should be able to say this will only ever be this image. Do not allow anybody to overwrite this image. But you can't, and I think that should exist. I believe Harbor does actually have some support for this now. I've not looked into the details. The other thing that comes out is like this is interesting metadata, like the Git hash and the date and build number, that you kind of want to be able to see. And rather than pushing everything into the tag, what you should do is use something called labels. And there's actually something called annotations in the OCI image spec. And this is the org open containers image thing. And that defines basically some tags you can use. So you can see I've like created the authors, created the version, which is the full Git hash, the repo and so on. And I've set that as these standard tags. And by using standard tags, one of the nice possibilities is that you can potentially surface that in different areas. So, for example, in the trial registry, we could start automatically displaying anything in our containers image, or using that, in certain parts of the UI, for example. So that's a complete aside. I've gone a little bit off track, but that is something I strongly urge people to look at. And it brings us nicely on to the next point, which is discoverability. And really searching and listing what is in a container registry seems pretty poor at the minute. And I would like from the CLI as well as from a UI to be able to do things like that. And I should be able to do things like search by digest and get back all the different tags that's pointing to over time. So if it's been like Zodus latest, I should know. If it's been Zodus 0.1, it should tell me that and when. And as a mutable tag like the git hash, can I see that as well? Tag history, which is what I showed you with the manifest history. And also, I would like to be able to get back to sort of metadata on an image easily without necessarily downloading the whole image, and potentially be able to search for that. So, if I could search for everything that Container Solutions Labs ever made. There's no really good reason why you can't do that today. Okay, so the next pod, if you look at the Hello pod, and we dive down, we can see it's running this Nginx demos Hello image. And then if you go to Docker Hub, you'll find that's a 3-year-old image, and potentially, well, probably full of using a vulnerable version of Nginx, and potentially putting your organization at risk. So, you definitely want to stop that from running. Probably have words with the developer or ops person that put it up. Presumably it was just a test or something that's been forgotten about. But you'd also really like to put in place some sort of process to stop it from happening again. And I think this is kind of another thing that's kind of lacking a little bit in Kubernetes, because you kind of want to have good controls over what you can run in the cluster. So as one simple example or a common request, you want to be able to say something like, okay, allow images from my organization's registries to run. So if we're Fantastic Corp, allow Fantastic Corp.com images like Zodus to run. Also potentially allow official images from the Docker Hub, so the vetted images like Redis and Nginx, allow those to run. But you probably don't want to allow things like the user images, so things like Nginx demo /hello, or anything that's a sort of 2-part name, unless you've whitelisted it to run. And it's certainly possible to set that up in Kubernetes, but it is a bit of a pain at the minute. The sort of normal way to do it is to set up something called a validating admission webhook. So a validating admission webhook is something that gets a chance to run when you do your kubectl apply. That's the word I'm looking for. So when you do your kubectl apply, the validating admission webhook gets a chance to run, and it looks at the YAML, or I guess probably is it the YAML? Or whatever version it gets to look at and process that, and it gets a chance to say, yes, this deployment is allowed, or no, it's not. So in our case, what you want to do is look at the image tags for all, the image names for all your containers in the deployment or whatever, or daemon set or whatever it is, and say if they're allowed to run or not. And you can set that up yourself. It's not particularly hard, but the code has to run somewhere. So typically you end up with like another deployment to run your validating admission webhook, and you've got to write that somewhere, and he's got to set up all the config. Another way to do it is to use Open Policy Agent, and this is actually one of the very first examples on the website. So that's definitely a good way to do things. Or, and you'll be shocked to hear, Trow also does this, and it's actually one of the first things I did in Trow. So you can set Trow up to serve a validating admission webhook, and this is the config. So if I run the logs, Trow prints out its config when it starts up, and it tells me which prefixes are allowed. So by default, basically, it says all images within the Trow registry will be allowed, and I will do a verification to make sure that the image exists in the registry, which is one of the ways in which Trow integrates integration with the cluster gives us sort of an advantage. But basically, so any image in the TietoEVRY registry will be allowed by default. And any external image will not be allowed by default. And then you can override those defaults, if you like, by providing block or allow lists. So in this case, well, actually, this is the complete default. So by default, it will also allow anything under k8s.gcr.io, which is the Kubernetes system images. Basically, when I first wrote this, I didn't have that, and then everything breaks because it stops allowing the Kubernetes images to run, which is a problem. And it also allows Trio itself to run. These are prefixes. So this will allow any version of Trio to run, and this will allow anything under k8s.gcr.io to run. As long as it matches the string, the start of the string matches that. You can also specify exact names. So, you could specify Trio version 0.2 if you want exactly version 0.2 and you didn't want 0.2 alpha A, for example. And local images are the other way around. So you can remember local images are allowed by default. So anything you put in these lists will be denied. So one useful thing you could do is say anything under like your testing repository should not be allowed to run in the production cluster, for example. And you could do that using this mechanism. Okay, how am I doing for time? Oh, 25 minutes. I do have a demo. I wasn't quite sure if I was going to have enough time for the demo. I think we should be okay, though. Distribution. So, yeah, again, I think there's more we can be doing to actually just improve how images are distributed to a cluster. So imagine we've got Zodus running. It's been running in production for a while. It runs the daemon set. So you've got one instance of Zodus per node in the Fantastic Corp cluster, which is quite a large cluster, say 100 or so nodes. Yeah, that's a cluster. And then one day, something, as it always does, goes wrong. And we need to push out. We have a look, and it's actually pretty something trivial in Zodus, and we have a fix ready. We have a fix ready in like 10 minutes, but when we do like the kubectl apply, it still takes around 25 minutes before the change is propagated to all our Zodus nodes. And 25 minutes is a long time for an outage to be ongoing. So why does it take so long? And this isn't, I'm not stretching things here. It's quite possible that it would take that long in Kubernetes. If we have a daemon set that's using the roll and update, typically you'll only be updating one pod at a time. You might have like it does depend on the max surge and the what's the other one? Max unavailable settings or minimum available. I can't remember. But it's 1 or a percentage basically of pods will be being updated at a time, and the next pod doesn't start updating, doesn't even start pulling the image until the last pod is updated and passes the readiness test. So for example, if you have 100 nodes, we're running as a daemon set, remember. So each node has to pull the image separately. It's not like it won't be in the cache. And say it takes 10 seconds to pull the image. But say if you've got a large image of say like 600 megabytes, that's quite possible, even fast. And say you take 5 seconds for the container to start and for it to pass the readiness check. So that's 100 times 10 plus 5, so 1,500 seconds, or 25 minutes in total. But the worst bit of that is 17 minutes of that time is spent just pulling images. And that's actually a bit silly because we can do that much, much, much better. There's actually very little reason that you can't do that in 10 seconds. So we're talking about going from 17 minutes, in this case of an outage, to 10 seconds. And that's a big gain. And even if it's not an outage, you're just normally developing, it's much better to get feedback fast and be able to react quicker and not just make your day quicker and everybody more productive. And that isn't something we can do a lot better. So if you go and look today you will find stuff like Kraken from Uber and Dragonfly, originally by Alibaba, now from the CNCF. Both of these projects use P2P. So you probably have heard of BitTorrent. It's the same kind of idea. When you pull an image, you can pull it from all the nodes in the cluster, and it'll get sent much, much faster. Yeah, so these solutions exist today, and they work, but they are kind of designed for sort of very large scale, like Alibaba and Uber sort of scale. And they do enforce certain things in your workflow, so you might find them a little bit hard to embed in your workflow and configure for your use case. So this is not something that's currently working in Try, but definitely one of my big focuses for the future. I really want to support a workflow where we have like very fast distribution of images. I mean, there's no reason why we can't send images to nodes before they need them. So for example, when you do the Docker push to upload the new version of the image to the registry, there's no reason that the image can't start being distributed at that point to the nodes. So it could even like be 0 seconds spent transferring, because by the time you've like run the kubectl apply, the image is already sitting on the node ready to run. Yeah, and this is exactly the sort of thing I want to look at Try and really sort of improve things there. Okay, I think we've got time for a demo. Yeah, I haven't had, I didn't have a lot of prep time, so this could go horribly wrong, which I'm sure you'll all enjoy. Right, first off, I've got to change my screen. So I'll unshare for a second. And then I will, let's see. So I know I'm not sharing anything yet. Basically, I just, before I started talking, I spun up a Kubernetes cluster in JKE, the Google Cloud. And I want the JCloud thing to connect. Cool. And then I will share my, let's hope I can find my terminal. This one. That looks good. Oh, it even pops up. That was quite nice. Okay. Oh, cool. So here I'm in my, this is, if you do a git checkout of Try, this is what you'll get basically. I am on a branch because I was playing with stuff. And then if we go to quick install, these are the quick install instructions. This isn't what you'd use for a proper install of Try in production, but it's quite handy for testing and stuff, because it basically does a bunch of hacks to set up TLS. Okay, so I did copy this gcloud command. Boom. So hopefully this will connect us to our cluster. Oh, actually, maybe I can. There we go. So I'm looking at my terminal now, so it might be sideways on for you. I hope my sound's still okay. So kubectl nodes. Please work. Yeah. So you can see, make this a bit bigger. I wonder why I'm supposed to resize this. Does it automatically get updated? Yeah, it does. Oh, that's nice. Okay, so we can see I've got 3 nodes. They've been up for 40 minutes, so I guess I've been talking for about 40 minutes. Kubectl get deploy namespaces. Yeah, so all that's running is the kube system stuff. Okay, so this is the install script for Try. It comes up with a big thing telling you what you're going to do and the steps it's going to take. So you run it on JKE. It tells me I need to create this cluster role binding, so I've got the rights to do what I need. So I'm going to do that first. It also tells me about opening the firewall. I've done that, already, so I don't need to worry about that, I hope. I hope this works. I didn't test it earlier, and sometimes things suddenly break. Okay. You can also set which namespace you want to run it in. It runs in kube public by default. Yeah, and it does like some hackery with certificates, which is Nice, because you're using TLS and you don't have to do any stupid things like call everything localhost and proxy it on. But in a production install, what you do is you obviously use a proper TLS. Well, it's not quite true, because you'd use ingress, it would have its own TLS, and then internally try might be talking on a different certificate. But it looks different in production than it does in the quick install method anyway. It does take a moment to approve the certificate. I'm not actually sure why. I think it's just to do with like how often the controller runs in Kubernetes. Okay, and there we go. It's approved certificate. One really annoying thing about Kubernetes is nodes. This certificate comes from the Kubernetes certificate authority that's set up in your cluster, but the nodes in your Kubernetes cluster don't actually trust that, because I guess at the node level you're sort of outside the Kubernetes network. So I have to tell all the nodes to trust it, which is a bit annoying. Do you wish to install certs on this host and configure etc host to allow access from this machine? So basically that's going to install the certs on my laptop, so I can do my Docker push or whatever. Then we've got the validating webhook. So this is the admission webhook I was talking about earlier that controls what you can run inside the cluster. I'm going to turn it on. Okay, so let's say if I do pull nginx, I probably already have this image. It might be a newer version though. Nope. So if we tag nginx alpine to be true. So what is running at true cube public 31,000, and my laptop's been set up to recognize true cube public as pointing at my cluster in JKE just by hacking etc hosts. I can show you that later if you're interested. And we'll push that. Is this the magic moment? Yeah, so that's us pushing up the image to Trow in the JKE. Then we can do kubectl create deploy Trow test image equal to, and it's that again. Does that look right? I think so. Okay, it's running. It's available already. Okay, so now I just want to show you that how the validation works. So I should say I do think this is probably the fastest way to like get a registry running in the Kubernetes cluster, by the way. So if you ever need a registry at the last minute locally, definitely check out the quick install for Trow. Right, so I want to show how the validation stuff works just briefly. So if I get an image from the Docker Hub, which is docker.io/nginx, which is actually just the same as nginx. I called it proxy. And now when you do kubectl get deployment proxy, it's not there yet. That could just be because it's downloading the image. But if we look at it, kubectl describe, look at it, proxy. What we actually say is error creating emission webhook validator.trow.io. So the validator inside the try registry denied the request. And it denied it because remote image nginx, remote as in the sense it's not within the try registry, my dog whining at the door, isn't allowed as it's not in this registry and it's not in the allowed list. So that's how validation works and lets you control what images are running in your cluster. Yeah, so this is just going to show you the config again. Will this work? We hit tab. Yes. Yeah. So got try version 0.3, and that config is exactly the same as the config I showed you before. And a couple of other things. We do have the catalog. So this is a standard. There's nothing really there. This is the standard catalog. Well, not standard. The OCI distribution spec does define sort of catalog API, or actually they're arguing a bit over it, but there are other registries you might find a catalog API, including Docker distribution, that allows you to list which repositories are available. But the exact way it works and the functionality is still debated, and whether it should be part of the spec at all is being debated. So that exists in Trow as well. Manifest history. So there only is going to be one version of this image. Is it? I call it Nginx Alpine. Yeah. If I uploaded a couple more, you obviously get more stuff there. But basically, you know, it's telling you that the gist is this, and this is the date that was uploaded on. Yeah, I think that's probably enough for a demo. It's getting a bit late. Let's just got a couple of slides that I want to share, and then we can wrap up. This one, yes. Okay. Yeah. So if we're looking at sort of where I think registries are going in the future, we're definitely looking at more artifact types. That's basically here today. What's not here today is people using it like that. So, you know, time will tell if like everybody does start uploading all the different things like jars and so on to registries. One thing that's not here, and I would like to see, is, you know, sort of more support for searching, auditing, and discoverability of images in registries. Immutable tags, definitely want to see. I think that's, again, possibly here, but not equally distributed. Yeah, and finally, I really want to see more advanced distribution stuff in sort of default registries. So more sort of P2P stuff and things like that. And in terms of Trow, I'm working on a whole bunch of things. The problem is just trying to decide what to work on next, or what to prioritize most. Vulnerability scanners, I definitely want to have integrations for things like TietoEVRY. I think we need a GUI. It does seem to be that people find things a lot easier to get going, and organizations like you know, having like a pane of glass where they can see what's going on. Full audit logs. I think registries really should be give you an insight into what's happening in your cluster. Immutable tags, talked about that, and yeah, the ahead of time image distribution, so P2P or whatever. Okay, so that was it. I haven't looked at comments, so I don't know if there's any questions, but there we go.
Awesome.
Thanks Adrian. That was great.
So
we do have
one. Go ahead, Matt.
Thanks, Nick. This is we've got it up on the screen there.
Yeah, I see it. It's quite cool, actually. I'm quite impressed with this platform, actually. Nev, that's a good question. And I'm not sure. I haven't really looked into it in depth. I think it's still being discussed a lot. And I'm not really quite sure what the status is, to be perfectly honest. That's one of the things that's on my rather large to-do list. So apologies that I can't give you a better answer there. Is that it?
Yeah, I think it's a super interesting space right now, though. I mean, you can see from some of the discussions that have been going on around the CNCF community around Artifact Hub. I don't know whether you've been following that that discussion, Adrian, around.
No.
So this was there was some what's the word muttering about this project, because it kind of span out of the. Originally around the operator space to have a vendor neutral operator.
I'm coming back and just grabbing the dog.
That's right.
Sorry, he was pointing.
It's all right. Yeah, so around having a vendor-neutral place for operators to live, but the conversation around that has now spread out to, there's a proof of concept actually up there already, I think, for Artifact Hub. Let's see whether I can...
I don't know that at all. Oh, send that to me, cool. One problem is there's like so many different places for conversations now. So there's conversations going on like the OCI distribution, like this OCI mailing list that I am on. So I get updates and all the changes to the conformance specs and so on. And there's definitely this talk there of all the different. Okay, cool.
Yeah, this is, I think at the minute there is definitely Helm charts in here, but it's the same kind of idea basically to have a single multi-binary kind of place where you can put stuff. So, for any kind of artifacts that you need in the cluster.
Cool. It's
been slightly controversial because it actually came out of a CNCF working group as opposed to being submitted through the sandbox kind of through the sandbox.
I remember seeing something about this now you mentioned that. Yeah, there was a bit of fuss at the time. Yeah.
Good. No, I'll definitely look at that. I missed that completely.
And do you have shares in Logo Generator?
No, I should do.
Elaborate pump and dump.
It's free, so they're not making money from it. Like they
that is really cool. I could have been knowing about that a few weeks ago. So my wife is starting a new business venture, and she asked me to help out with the logo. And she was using like Wix and Squarespace and stuff like that. And she found that they had a logo generator, but if you actually wanted to download the PNG or whatever to use it, you had to obviously pay for it or buy a package. So I ended up taking like a small screenshot of what she did generate and then spending time in Illustrator or Photoshop. And if I'd have known that was a thing, I could have saved all that pay.
I did actually go and try, after seeing this talk the first time, I did go and try Free Logo Generator, and it does work fantastically well.
Cool. And it gives you SVG as well, so it's a vector format, which you can then play with or get any resolution.
Yeah. Nice.
Yeah. Namecheap is a great company, though.
I think I do have I think one of my URLs is with them, domains is with them.
I really like your demo with the admission controller hooks as well, and that we're seeing that becomes really, really important going forward when you have hundreds and thousands of different images, making sure that they are from appropriate sources, and if you could couple that with some type of signing as well, where you can ensure that it's gone through the proper pipelines and testing and scanning and so forth. That's really, really important in these large environments.
Yeah, so I should really be on top of exactly what's going on in both like Notary as Nev pointed out, and also this OPA thing that I need to play with a lot more. It's Open Policy Agent. But yeah, that's definitely kind of exactly what I want to be looking at.
So I'd like to get in a shameless plug for if you're interested in hearing more from Adrian. He's going to be joining me on my podcast on the 22nd of June, which you can get all the details on our Twitter feed at We Jump Sharks. So I'm looking forward to that, Adrian. We'll talk more about Free Logo Generator.
I might actually tune into this one if you're going to discuss free logos. Yeah, sounds much more interesting than this cloud native nonsense. Different types of images, right?
Yeah.
Cool. Well, we've had no more questions coming in, so I think we can probably call this a night. I just wanted to thank both of our speakers again for being with us tonight, and two really awesome talks. Great to have you with us. And obviously, thank you again to everyone that's tuned in to watch us tonight. Not sure when the next one is going to be. Watch this space. We'll get something up on Meetup at some point. Cool.
Should we go to the pub?
For any more? Yeah, if only.
Yeah.
If only.
I missed the pub. Okay. Well,
Nice
thank you
one.
all.
Excellent.
Thanks
all.
folks. Bye.